Here we're going to be interpreting z-scores to see exactly what they're telling us. So here we have this scenario. It says the normal distribution of an adult Great Dane stands a mean of 33.8 inches at the shoulder with a standard deviation of 2.1 inches. The normal distribution of an adult German Shepherd stands a mean of 24.9 inches at the shoulder with a standard deviation of 1.44 inches. Anthony owns a Great Dane that stands at 36.6 inches at the shoulder, and Naomi owns a German Shepherd that stands at 27 inches at the shoulder. Who owns the taller dog relative to its breed? So according to its breed, who has the taller dog? Now for a problem like this, you don't necessarily have to have a distribution here. It's not really necessary, but I like to do it because it lends a good pictorial of what's going on. It's a good visual of seeing what's going on and making sure that whatever computations we're coming up with, they seem to match what the graph is saying. So the first thing that I want to do for here is I'm just going to standardize everything. I'm going to put in a mean of 0 right here, my origin, and then count off one standard deviation going up, and of course count down as we come the other way. And then once I have that, I'm just going to go through here. It says the normal distribution for a Great Dane stands a mean of 33.8 inches at the shoulder with a standard deviation of 2.1 inches. So I'm going to put all my information over here for the Great Dane. How about if I do GD right here for Great Dane? He's got a mean of 33.8 inches. It's 33.8. Mu is 33.8. With a standard deviation of 2.1 inches. So sigma is 2.1 inches. Then it says the normal distribution for an adult German Shepherd stands at 24.9 inches at the shoulder with a standard deviation of 1.44 inches. So I'm going to put the German Shepherd over here. He's got a mean mu of 24.9 inches. You can see it right there. With a standard deviation of 1.44 inches. So then what I'm going to do is I'm going to put in the mean and standard deviation for each breed here underneath our distribution here. So for the Great Dane, we have 33.8. And then we just count up the 2.1 as we go up, and then count down the 2.1 as we go down our number line. So this is 35.9. $38 and 40.1, and of course we count down. It's 31.7, and all we're doing is subtracting the 2.1. The 2.1 of its standard deviation. And then I'm also going to put in, for the German Shepherd, I'm going to put in the German Shepherd's parameters here. So this is 24.9. And then, of course, I'm going to count up the 1.44 and then count down, depending upon which way I'm going up my number line. Here's 26.34, 27.78, 29.22, and then of course we count down. We subtract the 1.44 as we go down. 23.46, 22.02, and then finally 20.58. So then it states that Anthony owns a Great Dane that stands at 36.6 inches. 36.6 inches. So there's an X of 36.6 inches. That's the size of Anthony's dog. And Naomi owns a German Shepherd that stands at 27 inches. So that's X is at 27. So now visually, again, 36.6. Well, that's greater than 33.8. We know that. So here's 35.9. And here's 38. So 36.6 is somewhere in between, right? I'm just going to eyeball it. I'm going to say it's probably right around here. We'll do the same for the German Shepherd. Naomi has a German Shepherd that's 27 inches at the shoulder. The average is 24.9, so her dog is also above average. Here's 26.34. Here's 27.78, so it's somewhere in here too. It's hard exactly where to pinpoint it. I'm just going to kind of eyeball it, but you know what? It's kind of too close to call. It's hard to tell. So how I can determine for sure is I'll go ahead and we'll find the z-scores for each one. So the z-score for the Great Dane here, we'll take the 36.6. We'll subtract out the 33.8. Right? That's going to give us 2.8. Except we need to put in the standard deviation. That's 2.1. So the Great Dane has a z-score of approximately 1.333, and we'll do 4 decimals. I guess that looks about 1.3333 visually. Hard to tell exactly, so that's why we'll do the z-scores. So we'll find the z-scores for the German Shepherd. That's going to be 27 minus the 24.9. That's 2.1. Of course, we have to include our standard deviation. That's 1.44. And we know that they're both above the average. So this has a z-score of approximately 1.4583. So since the German Shepherd is further, the German Shepherd is 1.4583 standard deviations above the average, while the Great Dane is 1.3333 standard deviations above the average. So since the German Shepherd is higher above the average, we can say that Naomi owns the taller dog.